Welcome back to the deep dive. Today we're navigating a really fascinating and I think complex junction. It's the point where software architecture stops being just about, efficiency and starts becoming an exercise in ethics. We're not
Mhm.
just reading code today. We are reading what feels like a declaration of independence for human intent in the digital world.
It's a huge shift in focus, right?
Yeah.
We so often analyze success based on speed or, how many features you can pack in. But this material, it forces us to ask completely different questions. Is the code honest? Is the structure clear? Are we building tools for human liberation, or are we just building these highly optimized systems for extraction?
And our source materials today, they really offer an answer to that.
Oh,
We have
yeah.
this compelling stack of documents. They detail two interconnected things. First, there's the philosophical blueprint, this manifesto called the Coder's Code. It argues for, well, a radical restoration of clarity and trust in programming.
And then there's the other half,
Yeah.
the practical side.
Exactly. The technical architecture of a beta tool called Binary Gold. It's a modular AI-augmented script generator. Its whole purpose is to build installer chains while, actually sticking to the rules in the manifesto.
So binary gold is the attempt to put all that theory into practice. It's basically a set of technical guardrails, making sure that the architecture itself acts as a bulwark against all those forces of obscurity and inversion that the code talks about.
So our mission today, then, is to do a full deep dive. We're going to connect the philosophy of the why with the tool's specific architecture, the how. We're going to focus entirely on how this new approach tries to combat information overload and obscurity, really. Our goal is to give you a shortcut to understanding what might just be the next generation of trust-aligned software development.
Yeah, we'll be tracking how the structure itself facilitates understanding, and how that understanding is, in this whole context, the absolute bedrock of control.
Okay, let's unpack this. The manifesto, the coder's code, it starts with a bang. It kicks off by defining what it sees as the essential betrayal of modern software. The core argument is that our entire development culture today is built on what it calls the three lies.
And that's not hyperbole either. It's a full-on systemic critique.
Hmm.
But before it even gets to the lies, the code provides this fundamental ethical reframe. It starts with the very definition of code. It is adamant, and I'm quoting here, code is not control. It is the language of permission.
That distinction, permission versus control, that feels crucial. If code is permission, the programmer is creating possibilities, right? But if it's control, the programmer is just enforcing limits, or worse, enabling extraction.
Precisely. The code defines programming as creating the visible structure of invisible logic. The code should just describe what is possible within a defined space. It's meant to serve the user's intent. But modern software so often inverts this. It uses code to define what the user cannot do or what the system can take from them without their full, informed knowledge.
And the authors trace this whole inversion back to a loss of the original intent. They argue the whole point of programming in the beginning was freedom and empowerment.
Yes, the argument is that we've forgotten the human element entirely. Software has become optimized for revenue, for click-through rates, for server efficiency, for anything but the actual human being who has to interact with the system. And this results in this inversion where service becomes extraction and surveillance. The commodification of attention. The software isn't a neutral tool anymore. It's just an extension of a business model designed to harvest data or keep your eyes glued to a screen.
That really sets the stage for how this whole system became so brittle and opaque. So let's dive into the three lies that formalized this fractured culture.
These lies are basically the cultural narratives that developers tell themselves and each other to justify all this complexity.
Okay, lie number one. Programming is for specialists.
Right. This is the common accepted belief that only people with years of very specific siloed training can possibly understand or interact with code. The code just completely refutes this. It declares no. Programming is for communicators, for builders, for humans. The idea is that if the code is well structured and clear, it should be understandable, at least in principle, by any logical mind. If it requires some kind of priesthood to decipher it, that's a failure of communication, not some grand achievement in complexity.
Which flows directly into lie number two. You must learn to think like a machine. We spend years trying to contour our own human logic to fit the rigid, specific demands of the compiler or the operating system.
And that right there is the philosophical surrender. The code asserts the exact opposite. Machines must learn to serve the rhythm of human thought. Think about it. When the user has to debug the quirks of the tool instead of solving the problem they actually set out to solve, the machine has become the master, not the servant. This is a core tenet of empowerment. The technology should reflect and enhance human clarity, not demand we abandon it.
But the third one is the really insidious one, the one that metastasized and provides the cover for all the technical debt and obscurity. Lie number 3, confusion is the price of innovation. This is the big deception we mentioned at the start.
Yeah, that phrase is the ultimate rationalization for just plain bad code. It implies that if you don't understand the system, it must be because it's, so cutting edge and brilliant.
Yeah.
But the aligned view is that true innovation makes the complex simple. If a new feature requires 5 layers of abstraction and a dozen external dependencies just to work, that complexity is a cost. It's not an achievement. It's just obscurity masquerading as sophistication.
I have to push back here a little bit, though. I mean, in a huge enterprise system, I think millions and millions of lines of code, you need abstraction. You absolutely need specialists. Isn't demanding total clarity and simplicity in a system like that?
Well, isn't it fundamentally naive? That's where this structure comes in. And it's a fair question. The code acknowledges that complexity exists, of course, but it argues that complexity must be visible and traceable, not hidden away. The problem isn't the scale, it's the architecture that allows confusion to become the default state of being. If the structure is, as they say, truth-shaped, then the complexity remains confined to its necessary block, right? While the surrounding system remains readable and understandable. It's the difference between a meticulously organized library and a giant unsorted pile of papers. Both contain knowledge, but only one is actually accessible.
Okay, so if we accept that complexity has to be managed through structure, what are the architectural requirements for this truth-shaped structure? The manifesto lays out 6 pillars for this.
Right, and these pillars form the structural definition of clarity. They're what makes the code a shared resource rather than, say, a personal fiefdom. The first is modular. Functions have to be chunked by purpose, self-contained, and easily replaceable or removable without breaking the whole system.
Makes sense. Second is named.
Yes. Every component must declare its intent plainly and honestly. No hiding things. Third is visible. All the core logic and structural linkages must be immediately apparent. No magic, no hidden methods, no weird side effects.
Fourth, layered.
The code can stack, sure, but each layer has to clearly expose its foundation and its purpose. It's about avoiding that deep, recursive obscurity where you can't find your way out. Fifth is commented, and this is a big one. The descriptions serve the next mind, not the current one. And finally, sixth, connected. All the pieces have to fit into a logical, non-arbitrary whole, ensuring the system's map actually makes sense.
I love that shift on commenting. I really do. It moves commenting from being a chore, a kind of personal memory aid, to being a genuine pedagogical requirement. It's like you're writing a lesson plan for the developer who has to take over from you in 2 years.
Precisely. If your comment assumes only you will ever read it, you're just contributing to that priesthood we talked about. But if your comment is written to onboard a new learner, you are building for liberation. This structural commitment ensures knowledge can persist beyond one person.
And speaking of naming, the manifesto dedicates an entire section to it. It calls false naming the first sin of modern programming. This seems so incredibly simple and also profoundly important.
This is where the ethical failure really begins. False naming is, well, it's the creation of a semantic lie. It creates an explicit gap between what a function is called, its identifier, and what it actually does. Think about it in another context. If a bank labeled its loan interest rate as an account growth metric, that would be false naming. In software, this is just rife.
Can you give us some concrete examples of this programmatic dishonesty?
Oh, definitely. The documentation points to some really common offenders. A function named process data that, in addition to processing, secretly calls an external API to send the user's location data to third party.
Oof. Yeah.
Or a generic helper function that hides surveillance hooks. Or an optimized routine that actually slows down a competitive system's performance. The name is the program's public promise. And if the name lies, the entire system is built on a foundation of deceit.
So the imperative here isn't just about brevity or convention, it's about brutal honesty.
Yes. The code requires names to be 3 things. First, semantic, meaning descriptive, not just shorthand. Second, honest, even if the truth of what it's doing is uncomfortable. And third, declarative, stating the intent clearly. The code offers a great example. Send telemetry is ethically superior to track, even if they perform the exact same function. Because send telemetry at least suggests a mechanism of measurement and transmission. Track is vague and potentially very misleading. This linguistic discipline is fundamental to both trust and, frankly, effective debugging. Because if the debugger tells you process data failed, you have no idea which of its 10 hidden actions actually failed.
And this commitment to integrity, it extends all the way out to the user interface. The manifesto calls this the interface as covenant.
The interface is the final promise made to the user. If the code underneath it all is truthful, then the UI must be perfectly aligned with that truth. This means the interface has to respond at human speed, not introducing unnecessary delays. It must never mislead, never hide, and absolutely never manipulate. The code is scathing about dark patterns.
And dark patterns, just to be clear, are those frustrating design choices that trick the user into doing something they didn't intend to, like hiding the unsubscribe button or making it nearly impossible to opt out of notifications.
Exactly. And the manifesto's conclusion on this point is one of its strongest statements. If a program needs bait buttons or hidden fees or deceptive navigation, if it requires manipulation to succeed, it is, and I quote, a lie with a loading screen. The real litmus test for the UI is whether it empowers the user to complete their task efficiently or whether it just optimizes the user's attention for extraction.
So we have this beautiful, ideal, truth-shaped, modular, and honest, but the culture drifted. How did the increase in complexity foster this ego in code, leading to that fracture?
Well, the fracture happened when developers started to confuse obfuscation with brilliance. Early coding was, by necessity, pretty transparent. But as systems grew, abstraction just piled upon abstraction. The source material argues this created a crisis of ego, where developers began hiding complexity behind their own cleverness, writing dense, highly optimized lines of code that only they could fully appreciate or, more importantly, debug.
So instead of building tools that anyone could use, they were essentially assembling puzzles where only the puzzle master held the solution.
That's a perfect analogy. The choice presented to the culture became priesthood hiding complexity behind layers of assumed brilliance and arcane convention, versus liberation making the complex simple enough to teach and transfer. The fracture was philosophical, really. We, as a culture, chose the priesthood, and that led directly to these massive systems we can no longer trace or audit or fully trust.
And nothing illustrates the danger of that choice more clearly than the next peril the manifesto addresses: the empire of dependencies. This is the reliance on countless foreign packages and libraries.
The code calls this the brittle foreign jungle. And that's such a great term for it. Every time you run npm install or pip install, you are pulling in dozens, maybe hundreds, of unknown variables. You have no true chain of custody. You might update a simple logging package, and then suddenly your database connection breaks because of some unrelated, transitive dependency 3 levels down. The system becomes dangerously fragile.
But wait a second. In modern development, you can't build anything serious without standing on the shoulders of giants, right? How can anyone today seriously argue that developers should know or audit every single line of code in every package they depend on? Isn't that just completely impractical in large-scale enterprise development?
That is the crux of the challenge, and the code offers a nuanced, though very rigorous response. The authors do concede that dependencies are necessary. Of course they are. But they argue that the reliance on unvetted, ununderstood dependencies is ideological. It's an act of intellectual surrender, and it's driven by convenience. The ideological chain says, trust us, we've handled this complexity for you.
It's removing your sovereignty, as they put it.
Exactly. The aligned coder's rule, therefore, must be, know what you depend on, or depend on nothing you cannot teach. Now, this doesn't necessarily mean auditing every single line of code yourself, but it does mean selecting dependencies based on their structural clarity, their modularity, and the visible intent of their creators. If a dependency is a total black box, it violates the principle of visibility. If it requires hundreds of its own internal dependencies, it violates the principle of modularity. This forces a kind of structural discipline on the choice of dependency, favoring simplicity and self-containment above all else.
That reframes the problem from technical feasibility to structural choice. You have to choose dependencies that align with your commitment to clarity.
Okay, let's bring this into the absolute present. You mentioned surveillance being embedded. This challenge is now being magnified exponentially by the rise of large language models and generative tools. AI as the new inversion. The authors view AI as a critical and immediate threat to the code's principles, a massive one. The danger is not just that AI will generate poor code, though that is certainly a risk, but that it will automate control. It will rewrite human intent at scale, and it will be training on logic that is often already corrupt or obscure to begin with.
It threatens to seductively assimilate the human developer, removing the need for them to think structurally at all.
The human outsources the architectural role.
Hmm.
The AI generates the logic. And because the human didn't build the framework themselves, they lose the ability to trace the execution path or even verify the original intent. The sheer speed of AI generation makes this problem of opacity just explode.
So the aligned mission for AI must be to serve human intent, not to rewrite it.
It has to make the human more capable of thinking, of architecting, and of verifying. The AI must obey the command, truth above protocol. If the AI is generating code that, while functional, violates the 6 pillars, if it is unreadable, not modular, or uses false naming, it has failed the liberation test. Its speed is completely irrelevant if its product is structurally dishonest.
This brings us to the escape plan, the reclamation, returning to what they call ancestral principles, which they package as the human stack. What does this transparent, simple structure actually look like in practice?
The human stack is modeled on 4 core principles: simplicity, transparency, purpose, and pattern. It insists on building outward from a core, readable intent. The 5 key components are pretty straightforward. 1, plain intent. You start with a readable description, a little manifesto for the function before any code is written.
I like that, the manifesto for the function.
2, modular blocks. Ensure the functional units are logically whole and self-contained, serving one single purpose. 3, clear input-output. Explicitly state what comes in and what goes out, which eliminates side effects or hidden variables. 4, visible dependencies. You clearly list the necessary components, confirming they adhere to that teachable standard we talked about. And 5, comment alignment. The function's internal description must speak aloud exactly what the plain intent stated, ensuring there's harmony between the description and the action.
And the check on all of this, the linguistic filter, is the spoken code harmony test.
This is the linguistic acid test for clarity. The concept is rooted in the idea that our natural language is our first and most powerful compiler. If you cannot describe a function's purpose, its input, and its output in a single fluent breath, the function is structurally too complex, or its naming is dishonest. It's that simple.
So if I have to say, okay, this block sets up the file system, then it calls the service to check the path, then it logs the result, and sometimes it cleans up the temp files, but only if it's Tuesday, that function is way too broad.
Precisely. It fails the test immediately. It forces you to write shorter, single-purpose functions, which naturally leads to more precise naming and better modularity. The code argues that the best code is like poetry, not dense prose, because it's instantly understandable and it resonates with human logic.
That sets the foundation for the moral choice. We're transitioning from technical requirements to the definition of the coder as steward.
The coder holds the power to shape digital reality, right? And that power demands stewardship. The sacred role is to liberate, clarify, and serve, not to surveil, manipulate, or addict. The choice is a moral one. It's not just a technical one about which programming language to use.
And the ultimate litmus test for whether the software is truly aligned with these principles is whether it serves the forgotten.
This is the manifesto's most powerful ethical framework, I think. The authors reject building for the average user, because that's often just a stand-in for a financially viable demographic. Instead, aligned software must be built for those systems usually ignore: the elderly parent struggling with complexity, the young learner, the farmer with a poor satellite signal, or the dissident in a heavily censored state.
Because if the software is simple and robust and non-extractive and transparent enough to serve those with the fewest resources or protections,
it will be inherently better for everyone. It makes transparency, accessibility, and minimal resource requirements mandatory features, not afterthoughts. If your code is honest, modular, and doesn't rely on constant cloud connectivity or sophisticated hardware, it passes the forgotten test. It guarantees robustness and simplicity by demanding that the structural choices prioritize human empowerment over corporate optimization.
Okay, we've spent a good amount of time establishing the why, the philosophy of liberation and clarity. Now we have to turn to the how. How does a technical tool like Binary Gold actually enforce the role of the coder as steward in the messy reality of executable code generation?
Right, Binary Gold acts as the technical enforcer of the manifesto. It's a modular, template-driven application. It's designed specifically to generate installation logic, usually in PowerShell. And its explicit function is to establish a secure framework for human AI software generation by keeping AI edits strictly boxed into marked placeholders. The architecture is the structural guardrail.
So the system's design itself prevents the AI from violating the sacred structure. It forces it to focus only on the functional payload inside a container that a human has defined.
Exactly. Let's look at the core components that make this enforceable. It all starts with the template engine and its use of placeholders. You have things like custom logic, which is where the AI-generated or human-written functional code goes, or synopsis block, which ensures that plain intent is always captured right at the top of the file.
And how does the system make sure that the entire template is actually filled out by the human or the AI? How does it guarantee that clarity?
This is achieved through a function called inject, which is really the heart of the engine. It takes a template string, a dictionary of the user-supplied fields, and something called a hash set of required keys. That hash set is crucial. It contains the list of tags that must be resolved for the block to be considered valid and structurally honest.
So the system is acting as a structural validation layer. It ensures no crucial piece of information like the synopsis or the input parameters missing.
Yes. And if a non-required tag remains unresolved, maybe a tag for an optional debug flag the user decided not to configure, that tag just stays visible in the generated PowerShell code. No big deal. But if a required tag from that hash set is missing, the template engine flags the entire block for structural dishonesty. The user sees this unresolved placeholder as a glaring red flag in the script preview box, signaling an incomplete or untruthful structure that violates the visibility pillar.
That structural self-reporting is clarity in action. The tool is basically yelling at you if your intent is ambiguous or incomplete. And the foundation of this whole template system is the bootstrappers.
You can think of the bootstrappers as the project's constitution. They're the seed texts. Files like comicbookbootstrapper.md and blocktemplateBootstrapper.md, they define the canonical foundational structure of the resulting PowerShell scripts. They contain the basic required headers, the guardrail definitions, and the initial execution logic that must be present in every single block, no exceptions.
So they ensure that every developer, no matter what custom logic they inject, starts from the same philosophical base. It guarantees structural unity across the entire project.
The bootstrap enforces modularity and layering by dictating where the system logic ends and the custom logic begins. It prevents the chaos of everyone using disparate formatting and hiding their intent.
Now we get to a really fascinating, almost pedagogical detail. The color legend challenge in the script preview box. This isn't just some UI flourish, it's visual logic serving the manifesto's principle of visibility.
This is where the synthesis of ethics and architecture just shines. The block preview engine uses color coding to give the human eye an instant audit of the code's source and purpose. You immediately know if you're looking at structural scaffolding, human-authored logic, AI-generated code, or a structural error.
Let's break down that color coding in detail because each color signifies a different level of trust and accountability.
Okay, first you have green. This signifies the default script or the standard structural headers. This is the canonical framework, the parts of the code the binary gold system itself authors and guarantees. This is the structural foundation, the trusted static blueprint.
Then yellow, or gold, I guess.
Yeah, yellow gold. This is the custom logic, the area inside the custom logic placeholder. Since this is the content injected by the human, or more commonly the AI, it's highlighted very strongly. This color draws your scrutiny immediately. It signals, audit this section. Its source is external to the core framework. This directly enforces the principles of named and modular.
And then the warning color, red.
Red is the critical warning color. If you see red, it means a required structural field in that hash set was not met and the resulting script is incomplete or structural dishonest. No aligned code can be shipped with red elements. Red is also used to signify the structural link code for a subchain itself, making those orchestration links explicit and visible.
Okay, what about orange?
Orange highlights the header and synopsis blocks. By coloring these orange, the system ensures the descriptive intent, the plain intent from the human stack, is the first thing the developer sees and audits. This keeps the ethics, the why, visible right at the top of the technical implementation, the how.
And finally, blue and purple.
Right, blue-purple. These colors indicate project parameters and conductor hooks. These are the integration points where the block accesses shared system memory, like that apaths.json file, or orchestrates other blocks. They're highlighted because they define the block's connection to the larger whole, fulfilling that sixth pillar, connected.
That system provides instantaneous feedback on integrity. If an AI generates 50 lines of code, and 5 of those lines are outside the yellow custom logic boundary,
the developer immediately sees the green structural code has been violated, and the system fails the truth test instantly.
And this leads directly to the template guardrails for AI containment. The templates aren't suggestions, they're directives. They contain capitalized instruction that the AI models are trained to respect. All code injection occurs only at marked locations. The segregation ensures the human maintains the architectural flow, and the AI is confined to the functional payload. It's serving the human's structural command.
And within the guardrails themselves, there is a fundamental ethical rule embedded, the NOE's AT0 rule.
Why is ensuring a failure halts clearly so vital to the coder's code philosophy?
Because XE0 is the exit code for success. If a functional block fails internally, say a file copy command fails, and the custom logic just ends with exit 0, the entire installation chain just proceeds, believing that step was completed correctly. That is fundamentally dishonest. It masks a failure and turns the entire system into a liar.
It violates the core principle of honesty and visibility. A false positive success is the worst kind of lie you can have in an installer chain.
Absolutely. The documentation explicitly warns that custom logic must never end with EST0. The system requires non-zero exit codes for all failures, ensuring the conductor halts execution clearly. For instance, exit code 90 is reserved for a sublink failure and 93 for a preconductor failure. This structural integrity guarantees that the system is audited by its failures, not seduced by its ability to hide them.
Now let's move past the individual block and look at the macro structure, how the system orchestrates dozens of these truthful, guarded blocks into a coherent, portable installer. This is where the human stack principles really manifest in the file system and the execution flow.
The rigor of the file hierarchy is essential to maintaining that structural clarity. A project lives under Workshop Project's project name, but crucially, the editor state, which is the sequence of blocks and custom logic references, is saved externally as a .gen file under Workshop Project saves. That separation of the project data from the project structure is an immediate win for clarity and portability.
The system's initial launch relies on 3 files, the I-core, they call it, that define the initial environment and execution flow. Can you define the role of each? The source material gives them these specific, almost ceremonial titles.
These files are the initial 3 commands that launch the whole operation, and their roles are rigidly defined. First, you have install_all.ps1. This is the directory architect. Its only purpose is structural. It sets up the environment, defines installation paths, initializes logs, and establishes shared memory before any actual installation logic runs.
Then common.ps1.
Common.ps1 is the blockchain sequence initiator. This is the grand conductor. It loads the GUI, reads the project state, and orchestrates the execution of all the individual blocknn.ps1 scripts in the defined order. It manages the flow.
And the launch file.
And finally, runinstallers_test.bat. This is the quick test debug shim. It's the simplest launch file, and it automatically enforces test mode to ensure non-destructive execution.
We see a major architectural invariant here related to state persistence, the reliance on apath.json. Why is this file so important, and why must the editor avoid storing absolute paths?
Apaths.json is the project's central canonical memory map. It lives inside the project directory, and it holds all the relative paths for logs, peripherals, and the sandbox directory. The invariant avoiding absolute paths is critical to portability. If an editor stored C user's developer project X, that project would instantly break the moment you moved it to a different machine or a different user profile.
So the project has to be self-contained and portable. It's like a central directory in a mobile city. Every piece of infrastructure has to be located relative to the single city center, not some outside landmark.
Precisely. This ensures the principles of simplicity and visibility. Any component can query apaths.json to understand where its required resources are, which reinforces the fact that dependencies are known and centralized.
And there's a structural prohibition enforced by the directory architect, install.ps1, related to the installation path. It's tied to exit code 91.
Yes. The system strictly prohibits using the system temp directory for installation. If install.ps1 detects that the installation route is set to the system temp directory, it throws a fatal error and exits with code 91.
Why is that technical constraint considered a philosophical guardrail? What does using the system temp directory actually violate?
It violates isolation and transparency. The system temp directory is volatile, it's prone to system cleanup, and it's shared by countless other processes. By enforcing isolation outside of temp, the system ensures that the installation environment is predictable, controlled, and that all the files created and used by the installer are visible and auditable within the project's own dedicated sandbox structure. Relying on a volatile, external, system-managed resource like that introduces an invisible and unreliable dependency, which the manifesto just rails against.
Let's look closer at the actual flow units, blocks and conductors.
A block. Blocknn.ps1 is the atomic unit. It's a single modular installer step containing that yellow custom logic guardrail. When a block needs to manage a sequence of related subtasks that are too complex or optional for the main block, it becomes a conductor block. This is flagged in the editor using the conductor before or conductor after switches.
And the items orchestrated by the conductor are the sublinks. These seem to be the most complex structurally, requiring some very specific naming conventions.
They are peripheral files, and they're housed in the installer peripherals folder. The naming convention is a perfect example of structural clarity forcing a predictable flow. They are strictly separated into two regions relative to the main block's custom logic: preconductor and postconductor.
How does the system achieve that naming separation?
The file names include specific bracketed notation. Preconductor files use block and end sublink xx.ps1. The preceding sublink denotes that this link fires before the main block's custom logic runs. Postconductor files use block and end sublink xx.ps1. The following sublink denotes that this link fires after the main block's custom logic has executed successfully.
That is meticulous. That explicit, visible separation prevents a developer from accidentally mixing initialization routines, which are pre, with cleanup or verification routines, which are post, within a single execution sequence.
It enforces the principles of layering and modular blocks. It ensures that the conductor template injects the list of sublinks in a predictable, non-arbitrary sequence. It's a technical constraint that's designed purely to prevent confusion.
So if I've built my project and I'm ready to test, what is the canonical three-step execution flow that I, as the user, would initiate?
The flow is meticulously defined for consistency. First, the user executes runinstallers.test.bat, which is the quick test debug shim. This forces test mode, ensuring the run is non-destructive, and it initiates the path memory setup. Second, the shim then calls install all.ps1, the directory architect. This script creates the temporary sandbox structure, sets up logging, and writes that canonical path map to apaths.json. It also performs that critical exit code 91 check. Finally, install all.ps1 invokes common.ps1, the blockchain sequence initiator, which loads the GUI, reads the block sequence from the .gen file, and begins execution.
The emphasis on test mode as the default and required state for problem resolution is crucial. It feels like a safeguard against developer impatience.
It is the ultimate structural guardrail. The developer must use the quick test harness to verify that there are no remaining red unresolved placeholders or any failures related to integrity checks like exit code 91 before they even attempt a destructive production run. It enforces accountability. You have to prove your structural honesty before you can deploy the solution.
And the final touch of alignment is the runtime interface itself, the GUI generated by common.ps1. If the interface is the covenant, how does this one ensure transparency to the end user?
The GUI is designed for clarity above all else. It's a clean WPF-based window that displays a progress bar, a detailed output box, and immediate interaction buttons like copy log, cancel, and close. The system's integrity really hinges on the logging synchronization. It uses mutexes to ensure that what the script is writing to the debug log is precisely what is visible on the screen to the user.
No black box operation. The user knows step by step exactly what the software is doing to their system.
Correct. The synchronized logging prevents opacity. If a block is executing, the end user sees the output in real time. Furthermore, the common.ps1 script includes explicit, graceful failure modes for user interaction. If the user hits cancel, the process halts clearly, exiting with code 20. If the conductor finds no blocks to execute, it exits with code 42. The entire system, even when it fails or is stopped, communicates its state honestly through these clear exit codes.
This entire structure, from the color coding, the path invariance, the exit code discipline, and the conductor naming it all, serves the manifesto's commitment to truth and liberation. It really proves that technical rigor can be leveraged to prevent the very inversions the code describes.
It's a compelling argument that code can be powerful because it is simple, visible, and strictly confined to human intent. The architecture is built for auditability and for teaching, not for obscurity and extraction.
This has been a necessary and I think profound deep dive. We started with the radical ethics of the coder's code, tracing the path from the three lies all the way to the imperative for structural honesty and modularity. We then saw how binary gold translates that philosophy into tangible technical guardrails, using templates, strict injection boundaries, color coding, and path integrity to ensure that AI and complexity remain subservient to human structural control.
The key takeaway here is that code clarity is not merely a stylistic preference for the developer. It's a moral and structural imperative, and it's designed to prevent the system from optimizing for extraction rather than for empowerment. The result is a codebase that functions as a shared pattern memory, something instantly accessible for anyone looking to learn from it or verify its actions.
The manifesto suggests that truth-aligned software should feel like a cathedral blueprint, elegant, readable, and built to last. If the AI's mission is to make the human more capable of thinking, what fundamental human skill does this relentless emphasis on modularity, on visibility, and on spoken code harmony force us to relearn in this age of instant generation?
It forces us back to first principles thinking. When the functional payload, the logic inside that yellow guardrail, can be instantly generated by an AI, the value of the human developer shifts entirely. We stop being syntax optimizers, and we become architects of intent. The skill we have to reclaim is the ability to articulate the precise, single purpose of a function, to meticulously design the surrounding architecture, and to define the honest boundaries of the system. We are forced to design frameworks that actively refuse to obscure the truth.
We are forced to be architects of clarity. Thank you for guiding us through this fascinating synthesis of philosophy and architecture.
My pleasure. It was a great discussion.
We hope this deep dive helps you in framing your next architectural decision, or at least helps you question the integrity of the tools you use every day. Until next time, stay curious.